I'm recording. Now I got to present my desktop. It's connecting. Okay, so on Wednesday we talked about the different types of angle. 90-degree angle. Of course, this is not drawn as 90 degrees, but if it's not and it does not look like it, but it always has this little box here in the corner, then you always take it as a 90-degree angle. Angle between 90 and 180 degrees is an obtuse angle. We said that an angle that's between 0 and 90 degrees is going to be an acute angle. We have a straight angle, a reflex angle, and then we have this angle that always just comes back on top of itself. And that, when we have this arrow drawn, is 360 degrees, or called a zero angle. Now, I did we're going to be looking at today what we call complementary and supplementary. So, as we're looking at complementary and supplementary angles, complementary or angles that add to 90 degrees. Supplementary angles add to 180 degrees. And I feel like I did this the other day, and I'm sorry, I'm going to look at my notes real quick. Yeah, so when we were talking about this on the first day, or last Wednesday, we were talking about when we have two parallel lines that are cut by a transversal, we said this angle plus this angle here are supplementary angles. And so they're going to form what we're talking about today, which is going to be the supplementary angles are 180 degrees. So if I have a Cartesian grid here, and let's say that this is coming directly up the center. So this is a 45-degree angle, and this is a 45-degree angle. And I know when I add the two 45 degrees together, I'm going to get 90 degrees. So angle A here and angle B are what we call complementary angles because they add up. So any angles that add up to 90 degrees are going to be complementary. You may come up with a question, what is the complement of angle 30 degrees? And the complement is going to be an angle that is 60 degrees. So when you're asking for a complement, you're just asking for what's the angle measure that's going to add up to be 90 degrees. The same thing goes with the supplementary angles. What is the complement of a 150-degree angle? Its supplement, is going to be 30 degrees because the two 150 plus 30 add to be 180. So watch how the wording is. What is the complement? No, you're not going to tell him that he's a cute little angle or whatever. You're going to say the complement of a 30-degree angle is 60 degrees. Now, these two angles here, angle A and angle B, are also called adjacent angles. So they're adjacent because they actually share a side in common. So when we were talking on Monday about intersecting lines, and I have these four angles. We call angle 1 and angle 3 vertical angles. Now, those of you who weren't on here on Wednesday, this little symbol is my abbreviation for angle. So angle 1 and angle 3 are vertical angles, and that would make angle 2 and angle 4 also vertical angles. Now, these vertical angles also have other things in common because these are intersecting lines. So if I have line L and line M here, I have adjacent lines, adjacent angles. So angle 1 and angle 2 are adjacent. Angle 1 and angle 2 are also going to make what type of angle? They're going to make the supplementary angle because line M is a line and we know that it's 180 degrees. So the same goes here. I know that angle 2 and angle 3 are supplementary because this line L is going to be 180 degrees. So these two adjacent angles are also supplementary angles. Now, because 1 and 3 and 2 and 4 are vertical angles, that means that they have the same measurement. So they are congruent. So they are the same size. So if I were to measure angle 1 and get that it was 15 degrees, I would measure angle 3 and see that it was 15 degrees. So since angle 1 and 3 are congruent, that makes angle, and I'm misspelling words, sorry, angle 2 and angle 4 also congruent. So they have the same measurement if I were to measure these. Now, another question I can ask here is, how many different supplementary angles do we have? So I have angles 1 and 4 that make up line L. I have angle 4 and 3 that makes up line M. I have angle 2 and 3 that we talked about that makes up L, and 2 and 1 that makes up M. So there are 4 sets of supplementary angles here on these two lines that are intersecting. So any questions? So let's go to what we're going to be talking about as the vertical angle theorem. I showed you where we just have an intersection with one point, and we have vertical angles, and we know that our vertical angles are going to be the same measurements, which are going to be congruent. But when we have two lines that are, and I'm drawing on my line so I can make sure I'm doing parallel lines here. And you see I'm not very good at doing that. So if I have line X and line Y, and I cut through these lines with a transversal, and now I'm going to label these just 1 through 8. Now in this one we have vertical angles, 4 sets of vertical angles, because I've got 2 parallel lines. And over here in my directions, I'm going to say that X and Y are parallel. And as we talked about on Wednesday, because I know these are parallel lines, I know that when I cut them with a transversal, I'm coming into line X at the same angle that I'm going to be coming into line Y. This angle is not going to bend in the middle and come back this direction or bend in another place. If I'm coming in straight through, y'all are seeing my notes, aren't you?
Yes.
Okay. So when I'm coming through one angle, the top line, then it's coming at the same angle through the bottom line. And so not only do we have vertical angles here, we also have what we call corresponding angles. And because we've got corresponding angles, that means angle 1 is going to correspond with angle 5. Because it's at the same position in both lines that are parallel. So that means that we have angle 1 and angle 5 are corresponding. Angle 3 is corresponding with angle 7. That means that we've got angle 2 and angle 6, angle 4, and angle 8. These are called corresponding angles. Now the one thing about these, because X and Y are parallel, and these are called corresponding angles, that means that they're also congruent. So I can say that angle 1 and angle 5 are equal to each other. They have the same measurement. Now a while ago we talked about we talked about supplementary and complementary angles that have adjacent angles. Well, here I have supplementary angles, but I could say that angle 1 and angle 7 are supplementary, but they're not adjacent. Since I know 1 and 3 are supplementary and they make up a line, 3 and 7 are congruent, therefore angle 1 and angle 7 are supplementary angles. Does everybody understand that? So what if I told you that, what if I give you that angle 8 here Angle 8 is about 46 degrees. Sorry, I'm going to rewrite this a little bit neater. Angle 8 equals 46 degrees. Now I want you to find the angle measurements of all the other angles in here. So when we were talking a while ago and we said that all of these corresponding angles are the same measurements, then I know that if I have angle 8, then I know its corresponding angle, angle 4, should also be 46 degrees. So if 8 equals 46 degrees, then angle 4 should also equal 46 degrees. Now, we also talked about just intersecting lines and vertical angles over their point of intersection. Vertical angles are also going to be the same measurement. So not only does angle 4 correspond to angle 8, but angle 5, this is a corresponding angle. Angle 5 is a vertical angle. And so it's also going to be 46 degrees. Now, if angle 5 is 46 degrees, angle 5's corresponding angle, angle 1, is going to be 46 degrees. And if you look here, angle 1 and angle 4 are vertical. So since angle 4 is 46, angle 1 is also going to be 46. Because it's a corresponding to angle 5, and angle 1 is vertical to angle 4. So we have all of these relationships going on here. So now I've got 4 angles that are 46 degrees. Now I've just got to find out the other 4. So we know that all of these, and if you want to mark them with a slash with a 1, with a little dash through there, then we know all of these angles equal the same thing. That's how I would mark them. Mark them with the angle symbol, and then a little line through them lets you know that they're all equal to the same measurement. Now, we call 1 and 3 supplementary. We call 4 and 2 supplementary, or 4 and 3 supplementary. So now we just need to take 180 and subtract 46. And I've got left 134 degrees. So that means that angle 3 is going to be 134 degrees. Because it's supplementary to angle 1. Well, angle 2 is going to be supplementary to 4, or it's vertical to angle 2. So we can say that angle 2 is, because it's vertical to angle 3. And then we have these corresponding angles again, because we said here that angle 3 and angle 7 are corresponding angles. And so we know that they're also going to be congruent. So we know that angle 7 and angle 6 are going to be 134 degrees. Now, if I were to take my protractor, try to read it upside down, it's going to be a little bit off, but everything else Everything else is off because I'm not really drawing out the lines like I should draw them out. Sorry about that, peoples. But we know that 134 plus 46 degrees is going to give us 180 degrees, and the 180 degrees are going to be my supplementary angles. If I start writing too low, y'all let me know so y'all can see what's going on. Now this rule only applies when X and Y are parallel and they are cut by a transversal. So this is the corresponding angles theorem, and this is how we can get this. Now I can have corresponding angles, but they will not, unless I'm told that these lines are parallel, they're not going to be the same measurement. They'll just be corresponding angles. They'll be at the same location, just on a different line. But yet they could have a different measurement. And so an example of that would be, okay, what if I had a line this direction and a line going this direction, and I was cut by this transversal? And I've labeled my angles. Well, I can say angle 1 and angle 5 are corresponding, but you can tell in the drawing that they're definitely not congruent. So corresponding angles we can have. They're not going to be congruent unless we're told that the two lines that they're cutting through is parallel. So I've labeled and given you some direction. So I'm going to pause the recording for right now. So as you are looking at these angles, these are two parallel angles actually given at a diagonal, but because I am told that they are parallel, if you have trouble seeing them because they're a different angle, then just rotate your paper so they actually look like they are going in a horizontal fashion across your paper as two parallel lines, just like we did before. So as I'm looking at these, I see that angle 1 and angle 7 are at the same spot on line X and line Y. So that's going to be one pair of corresponding angles, 1 and 7. Then I know that, excuse me, not corresponding, blah, blah. Stop me, peoples. Corresponding angles is going to be angle 1 and angle 3. Angle 5 and angle 7 are going to be another set of corresponding angles. Angle 2 and angle 4. Then we have 1 and 3, 2 and 4, 5 and 7, and then we have angle 6 and angle 8. These are all called corresponding angles. Now my vertical angles are going to be angle 1 and angle 6, angle 2 and angle 5, angle 3 and angle 4, no, angle 8, sorry, and angle 7 and angle 4. Now, we have things that are called, excuse me. Let's finish this up. If angle 5 is going to be 102 degrees, and I can look here and see that my corresponding angle to angle 5 is angle 7, so I know that if this is 102 degrees, then this angle also is going to be 102 degrees. So I can get this from my corresponding angles. Then I can look at my vertical angles and see that angle 2 and angle 5 are vertical. So then I know that angle 2 is also going to be 102 degrees. And angle 7 and angle 4 are vertical. So these are also going to be the same measurement. So 102 degrees, we have angle 5, angle 2, angle 4, and angle 7. And if my arithmetic is right, if I take 102 away from 180, then my supplementary angle is going to be 78 degrees. And so those are going to be the angles that are vertical to these, are adjacent to these angles, because they're going to make a supplementary angle. So this is going to be angle 1, angle 6, angle 3, and then angle 8. Now, you notice that angle 1 and angle 8 have the same measurement, but they're not corresponding angles or vertical angles here. We call angle 1 and angle 8 corresponding exterior angles. So corresponding exterior angles. And they're exterior because they're not inside between the two parallel lines. So if you think about that, these two right here, these 4 angles here are inside, so they're going to be interior. These 4 angles are outside the parallel, so these are going to be called exterior. So corresponding exterior angles is going to be angle 1 and angle 8. And then we have another one that's angle 5 and angle 4. And we've just shown that in several different ways, because we know that they have the same, angle 1 and 8 have the same measurement. And we also know that angle 1 and angle 6 are vertical, and if angle 6 and angle 8 are corresponding, then angle 1 and angle 8 can also be corresponding. So it's kind of like one of those proofs that you do in geometry that we always hated. We just proved that angle 1 and angle 8 can be corresponding exterior angles. That means that they're going to be congruent. So you just proved that by showing all of this. So then we have those angles that are called corresponding interior angles. And then we know that 2 and 7, because I marked them being the same, we know that angle 2 and angle 7 are going to be corresponding interior. And we know that angle 6 and angle 3 are also going to be corresponding interior angles. Now the last thing we're going to do right now is I'm going to draw a triangle on my paper. So if you want to draw a triangle, it can be any type of measurement, it doesn't matter. So this is triangle A, B, and C. Now if I'm looking at this triangle, I can actually number these angles. If I number 1, 2, 3, I can also number this one here where my A is 4. So I have angle 1 and angle 4. Now angle 1 and angle 4 are going to make what type of angle? Yes, you are correct. Supplementary angle. Because this is a line. If you extend the base of this triangle on out, it forms a line. So I know that if I know angle 4, I can find angle 1 by subtracting 180 degrees, or just the opposite. I can just do the opposite of that. Same thing goes with any of these. If I extend these lines on out that I have drawn, then they are going to form. So if this is angle 4, then this would be angle 5. And then if I extend this one out, it would be angle 6. So I could form all kinds of angles in here. But when you're looking at it, you know that a triangle is made with straight lines, because we talked about that. They're made with rays. So I know that this is going to keep going in this direction. This one will keep going here, and I can make one here to keep going that direction. So these rays are going to keep going, which form a straight line. So if I know one angle, I can always find the exterior of that angle. Now, if we were to draw a triangle, and let's say you had a pair of scissors and you cut the triangle out, and then you cut the tops off the points. Those points are going to be able, the tops of your triangle are going to be able to form a, don't know. Okay, so let's try it. I'm going to just get a plain sheet of white paper from the printer. That doesn't work. And I'm just going to fold it in half. Okay, so you see what I did. I just made a little triangle here. Okay, so what I want you to do is, this one needs to be trimmed up just a tad. So what I want you to do is, I want you to actually just cut these. Cut the little ends off of your triangle, tear them off. And these little ends are going to form a what? And that's what I want you to find out. So it's just like taking the triangle that I drew, taking its ends off. And then we have a straight line here, or you can do it on the bottom of your protractor if you've got it. But just try to see what you've got. So if I've got so if I have a line here, see what you can do with these pieces. Rearrange, do what you can do. Make sure you remember which one is the piece that was actually on the triangle and not the piece that you cut off. And once you get through manipulating these and turning these the way they need to be done, you're actually going to come up with a straight line. So when you turn these angles, and mine are sticking together. Here you go. So when you turn these angles like they need to be turned, I'm getting frustrated. Then they're going to form a straight line, because the interior angles of a triangle are going to add up. So we know that angle 1 plus angle 2 plus angle 3 are going to add up to be 180 degrees. And because of that, we should be able to take off their little tips here, add those three angles together. So this was the tip of one point. This is see, I've just screwed up, people. Hey guys, I'm gonna do it really quick. Okay, so I'm going to mark my angles. This is going to be angle 1, angle 2, and angle 3. Since I'm tearing my paper, that's going to be the best way to do it. And if I just tear off the angle, so I'm just taking it and ripping it. These three angles here are going to add up to be 180 degrees. So when I turn them, manipulate them, and put them on this scale that I have here on this line, then they should end up being 180 degrees as you manipulate them on around and stuff. So you can try that at home, and hopefully it works a lot better than me. Get some scissors and cut it out if you can. Works better than me tearing up an angle, because then you're not really sure which side goes where, and you may mess up things. Now the last little thing in this section is going to be when we're looking at angles and we have a protractor, and I'm trying to look at my protractor and decide what's going to go happen. The protractor is set up so I can actually read an angle. This protractor is actually set up so this side starts with 0 and the inside always goes to 180 degrees here, or it starts with 0 and goes to 180 degrees on the outside. So I could read my angle in any direction that I needed to. But generally, we are always told that if the angle is going this direction, this is always called our initial side. And this is the way I want you to read the angle. And this is called the terminating side. So no matter how you are reading the angle, so let's say instead of going this direction, I actually want you to read this angle this direction. So this is still called the initial side. And this is called our terminating side. So whichever one is going to be, wherever I start, is going to be the initial side. Wherever I'm ending up is going to be my terminating side. Now, because I know I'm going this direction, I know that I'm going to be adding, I'm going to have 180 degrees, and then I'm adding so many degrees to that. Or I know that if I go in a complete circle, I have 360 degrees. So if I actually read this, going this direction, I'm at 150 degrees. So I'm going to say 360 minus 150. Or as I told you, this outside realm here goes 0, 10, 20, 30. But I already have 180 degrees. So 90, 180, 190, 200, 210 degrees. I would say that this line is on 210 degrees, this angle. So it depends on how your protractor works as far as can you read. I wish I could focus this a whole lot better. Okay, I'm going to try just to pull it up. So as you look at the protractor, you can see that I have a 0 here, and this 0 from the inside is going to go up, the inside one. And then I have a 0 here, but on the outside it's going from 0 to 180 over here. So no matter which way you're looking, that's how I did this one, was say, okay, I know that from here to here is 180, and then 190, 200, 210 degrees. So I can do my angles this direction. So we are through with the 9.1, and I actually went into a lot more detail than I probably should have. But we are going to start on number 10. So we're moving to 10.1. It's 5/22/20. Now in your books, ebooks on page 488 and 489, there's actually some little things that you can do, and if you go on to Clemson and do their education classes, then you're actually going to be doing some of this there as far as, okay, how did they do that, the estimate, the error, the actual cut. And I'm going to slide my book over so you can see where they kind of got this from. Now, my mom sews a lot, and if she goes into a store, or especially a thrift store, because that's her nemesis, is a thrift store. If she goes into a thrift store and she sees a piece of cloth that she likes, or possibly a set of curtains that she likes, and there's no measurement, and yes, she does carry a tape measure in her pocketbook, so in case one of those rare days that she doesn't have it, she actually will hold up cloth and hold it in her fingers, pinch it between her fingers as far as she can pinch it, and stretch it out and do it to her nose, and she knows that that's approximately a yard. Now, this is different ways that you can look. Here is a cubit if you're looking at from your elbow to the tips of your finger. Your heel to the toes is called a foot. You have a hand, which does not include your thumb. and then the span includes your thumb. Now, the little tip end of my fingernail here, if I was to get a ruler, the tip end of my fingernail, not this whole fingernail, but the tip end of my fingernail measures about 1 centimeter, 1 millimeter. So if I wanted to go through here and count millimeters, I could do just like this, you know, have my fingernail down and count, which would be very painful. If I look and I take a measurement, and I know this because I've done it before, and I measure between these two knuckles, that's approximately an inch. So if I wanted to know about how big something was, and I had that, I could do that. That's approximately an inch. Now, if sometimes they're saying if your body's proportional to each other or whatever, that the height of your body is going to be the same as if you stretch your arms out beside you and you measure from fingertip, middle fingertip to middle fingertip, then that's going to be the same as your height. Now you can try that. That's something easy enough. Just put a clipboard or something on your head to keep it straight going back from the crown of your head and mark your height, measurement, and then get somebody to mark your fingertips and then measure that, and that should be about the same. So if you are trying to find something, and I know that I was 5'2" when I started getting measured. Now I know the older you get, the more you shrink. So I may have gotten shorter, but if I go and see and I need something that's going to fit in a certain spot in my house, and I know that my arm span is going to be roughly 5 feet, I could actually look at it and hold my arms up against it. Excuse me. Hold my arms up against it and see, okay, well, this is going to be way too long for the spot that I need it in. So people do this a lot. I do have a little tape measure that I carry in my pocketbook, as long as my granddaughter has not taken it out to measure. I found this. I have a bunch of these that are different colors, and she calls them her rainbows. So anybody that's doing preschool, that's something new. I've got a purple and an orange and the blue and a green and some other color, and she calls them rainbows because they look like a rainbow. And she plays with her rainbows outside and traces them with colored chalk. So you know, find different ways that you can do measurements and see. Also, measure your stride. I know that my dad, a lot of times when he's measuring a piece of property or measuring a building, if it says it's a certain size, he will actually go out and walk it. And that's called your stride. And you measure from your heel, from where your heel is, so you put your heel up against whatever, and then you measure out to where your toe touches on your other foot. So you can measure, because that's going to give you that span. So you can go out and say, okay, from here to here, from here to here. Or from your heel, okay, my left heel goes down. You can measure to where your left heel goes down the next time and measure that. And then you know, okay, every time my left foot goes down, I've measured out a yard, which is 3 feet. And that's generally what his is. And he can control his stride so it does equal the 3 feet each time. So as you're doing measurement processes, you can do this. Now, when we measure objects, we're always used to measuring something in inches or centimeters, but you can measure it in, if you have a pencil, a brand new pencil that hasn't been sharpened, you can measure in something as pencils. These are different units to measure in. So there's other units to measure in, especially when you're doing with kids. You know, preschool and sometimes special ed can't read a ruler. And so you're trying to figure out how can they do this. Well, a brand new pencil that hasn't been sharpened is going to be generally the same length as all the other brand new pencils that haven't been sharpened. So you could measure it in a pencil length. You could do, just like I said, everybody get out a bill, a dollar bill or whatever type of bill you have there, and measure it. My mom knows that a dollar bill or bill is so long and so wide. So when she's going out and measuring a table, she'll actually pull out sometimes a dollar bill if she needs an end table or whatever, a certain size, and she'll measure it with a dollar bill. So measure the length and the width, and this is something you need to report back to me between now and Monday. Those of you who are listening and haven't left me, you need to let me know what the length and the width is of a dollar bill. And if you don't have a $1, then your $50 bill that you have in your pocket will be fine. But don't use a $1 coin, which I have those too. And decide, okay, what is going to be the length and the width, and how can I figure this out? Now, we measure in a U.S. system or what they call an English system. U.S. system or English system of measure. We don't do a metric system. If you were in class with me, we would find the difference between measurements in English and the English system and metric system, but we don't. You do need to know that an inch is 1/12 of a foot, because we know that 12 inches makes up 1 foot. Now, if 1 inch is 1/12 of a foot, what is 1 square inch? That means that I've got an inch times an inch. So if this is 1 inch times 1 inch, then this is going to be an inch square. And I know that 1/12 of an inch, 1/12 of a foot is an inch. So what about 1 square inch? Then it's going to be 1/12 times 1/12. And that's going to be 1/144 feet squared. Now, on page 494 and 495, you're going to see units and their abbreviations and also their symbol that you use. You're going to need to know that, and especially on page 496, you're going to need to know the metric units. Now, I'll be honest, the metric is going to be actually easier than the English units when we're talking about conversions. So the metric unit and then the conversions. So you need to know, look at these pages. I am going to post some more homework, but because we need to get moving on these, and I apologize, but 10.1 that we're looking at now is talking about the English units of measure and the metric units of measure. And you're going to need to know these. So I would actually pull up on your ebook. You're going to do, we'll do weight, length, temperature. I think that's all. The length, the weight. Yeah, and the temperature. And this is going to be in US and metric. Now, when you have your test, just like normal with when you were in my classroom, you can have a sheet out there with these conversion factors on there. But the problem is going to be is that your test is timed. And so for you to be able to look at the conversion factors and try to look at how to work them out with it, it's going to be time consuming. So I want you to go through and look and see all of these units. Now, just to be practicing, let's say I have something that is 2.5 feet and I need to buy a wood strip or whatever, and it is sold in inches. Now I know this is a very crazy problem, but this is some things that you come up with. So I know that it's 2.5 feet, but I need to buy a wood strip that's only sold in inches. So you need to know that there is 12 inches equals 1 foot. And like I said, everybody should know this, so if it seems kind of silly that I'm doing something like this, but do something basic to work it out. So as I'm looking, I'm going to change this and actually to a mixed number. So my 2.5 feet are going to end up being 2 times 2 is 4 plus 1 is 5. So I got 5 halves is the same thing as 2.5 feet. Now, conversions, I want this conversion to end up in inches. And this is the reason I put inches here, is because when I cancel out through here, I want inches to be the thing that's in my numerator. So you got to figure out, how am I going to set this up? So I know that I have 5 halves of a foot, and I'm multiplying that times this conversion factor. So that means I want inches to be on the end. I want to cancel my foot. So that means I'm going to put my 12 inches in the numerator here and 1 foot in the denominator. So this shows that my foot is going to cancel here. And now I'm left with 5 halves times 12 inches. So 5 times 12 is 60. Divided by 2, because 2 times 1 is 2. And so I end up with 30 inches. And I thought it'd be better writing in pencil, but it's not showing up as good. So these are called, and if you've taken any science in high school, you know this is called a conversion factor here. So my conversion factors are going to be important that I know, and these are going to be equal to each other. So I know that there's 3 feet in 1 yard, that's a conversion factor. There's 8 ounces in a cup and 16 ounces in a pound. So you need to know whether you're doing weight or whether you're doing liquid weight or mass weight. And that's going to depend on different things too. So when you're looking at these, this is 10.1 and it is in your book from page 388 all the way to 388 to page 500 actually gives you all the different conversions that you need to be looking at. So any questions with what I just did?